As we know that when we talk about universe and especially when we talk about the creation of universe, how this universe works and what exactly is happening right here in the blank space, and how these stars and how this explosion, how these black holes were created, we end up with very one special word which is known as Big Bang Theory. Yes, in this podcast we're going to discuss whole Big Bang Theory in scientific manners, in scientific way. I will explain you a bunch of facts about this particular theory. I will tell you some history about this particular theory, and we will talk about some stuff which is related to this theory. In this episode there is no Vedic explanation of universe creation, because we have created, or we have thought about it that we should make a separate podcast for that. So in the part 2 of this particular episode, we will be talking about the same thing, same universe creation in Vedic manners, in ancient Indian text manners. So let's start this episode, and welcome to Knowell series again. And in this episode we will be talking about the Big Bang Theory. There is unique interest among scientists, astronomers and cosmologists is that the universe as we know it was created in massive explosion, and this massive explosion is known as Big Bang Theory. Let me tell you the exact definition of Big Bang Theory, and I would say it's not exact definition because there is no particular definition for this theory. I mean, clear definition. Big Bang Theory is how actually astronomers explain the way universe began. So it's just idea, it's just a concept, but it's just getting stronger and stronger day by day, research by research, because it's just proving itself after various researches. So in starting phases of this particular theory, when this theory came into the game, this theory was not quite popular, but after some researches like dark matter, black holes, and when this things just explored by scientists, and when they found similarities or I would say connections with this Big Bang theories, they appreciated it very well, and that's why this theory is very popular. Even if you are a kid, you may have heard about this particular theory. Even if you don't have any science background in your student life, even then also you may heard about this particular word because it's very popular. So basically this particular theory is not as complex as it sounds. It's very simple. The basic of the theory are very fairly simple. In short, the Big Bang Theory hypothesis states that all of the current and past matter in the universe came into existence at the same time, roughly 13.8 billion years ago. Again, this is the roughly calculated time after researching lots of things like age of stars and age of galaxies and all this stuff. So they calculated this rough time 13.8 billion years ago. So at this time, all matter was compacted into a very small ball with infinite density and intense heat called singularity. Suddenly the singularity began expanding and the universe as we know it began. While this is not the only modern theory of how universe came into being, for example, there is the steady state theory or the oscillating universe theory. It is the most widely accepted and popular. Not only does the model explain the origin of all known matter, but also it explains the law of physics and the large scale structure of universe. It also accounts for the expansion of the universe and broad range of other phenomena. So that's how this theory is very popular. The steady state theory, which is just came into game lately, and it's popular just because it is explaining matters and laws of physics and all these things at the scale of universe. So that's why it's popular. So let's talk about the timeline of this particular Big Bang theory. Working backwards from the current state of universe, scientists have theorized that it must have oriented at a single point of the infinite density and finite time that began to expand, as I explained you. After the initial expansion, the theory maintains the universe cooled sufficiently to allow the formation of subatomic particles and later simple atoms. Giant clouds of these primordial elements later coalesced through gravity to form stars and galaxies. This all began roughly 13.8 billion years ago, as you know, I have told you in the starting of this podcast. And that is why it's considered to be the age of the universe. Astronomical studies that have observed the deep universes, scientists have constructed a timeline of events that began with the Big Bang theory and has led to the current state of cosmic evolution. Now let me tell you about some facts about the singularity thing, because as I have told you that the very small ball with infinite density and intense heat is called singularity. So let's understand this singularity in depth. Singularity is known as Planck era also. This was the earliest known period of the universe, as you know, because universe started from here. At this time all matter was condensed on a single point of intense density and extreme heat. During this period, it is believed that the quantum effects of gravity dominated physical interaction and that no other physical forces were of equal strength to gravitation. This Planck period of time extends from 0 to approximately 10 to 43 seconds and is so named because it can only be measured in Planck time. Due to the extreme heat and density of matter, the state of the universe was highly unstable, because you know that every physics law is just getting destroyed at this particular time. Now let's talk about how predictions are made based on this Big Bang theories. So I will be talking about some long-term predictions for this particular theory. Hypothesizing that the universe had a starting point naturally gives rise to questions about a possible end point. So the question is, if the universe began as a tiny point of infinite density that started to expand, does that mean it will continue to expand indefinitely? So this is a very basic question that comes into our mind, of course. Another question is that will it one day run out of expansive force and begin retreating inward until all matter crunches back into a tiny ball? So answering this question has been a major focus of cosmologists ever since the debate about which model of the universe was correct one began. With the acceptance of the Big Bang theory, but prior to the observation of dark energy in the 1990s, cosmologists had came to agree on two scenarios as being the most likely outcomes for our universe. In the first, commonly known as the Big Crunch scenario, the universe will reach a maximum size and then begin to collapse it on itself. This will only be possible if the mass density of the universe is greater than the critical density. In other words, as long as the density of matter remains at or above a certain value, the universe will eventually contract. The universe would go on until star formation eventually ceased with the consumption of all the interstellar gas in each galaxy. Meanwhile, all existing stars would burn out and become white dwarfs, neutron stars and black holes. Very gradually, collision between these black holes would result in mass accumulating into a larger and larger black holes. The average temperature of the universe would approach absolute zero and black holes would evaporate and after emitting the last of their Hawking radiation, and this scenario is known as heat death, as you know. Other explanation of this Big Bang theory is that ultimately galaxy clusters, stars, planets, atoms, even nuclei and matter itself will be torn apart by their ever increasing expansion. This scenario is known as the Big Rip, in which the expansion of universe itself will eventually be its undoing. Let's talk about the history of this Big Bang theory. The earliest indication of the Big Bang occurred as a result of deep space observation conducted in the early 20th century. In 1912, American astronomer Westo Slipher conducted a series of observations of spiral galaxies and measured their Doppler redshift. In almost all cases, the spiral galaxies were observed to be moving away from our own. In 1924, Edwin Hubble measures the great distance to the nearest spiral nebula, showed that this system were indeed other galaxies. At the same time, Hubble began developing a series of distance indicators using the 100-inch Hooker telescope, Mount Wilson Observatory. And by 1929, Hubble discovered a correlation between distance and recession velocity, which is known as Hubble law. Other theories were advocated during this time as well, such as the Milne model and the oscillatory universe model. Both of these theories were based on Einstein's theory of general relativity and held that the universe follows infinite or indefinite self-sustaining cycles. Significant progress was made by time thanks to advances in telescope satellites and computer simulations, which have allowed astronomers and cosmologists to see more of the universe and gain a better understanding of its true age. The introduction of space telescopes such as Cosmetic Background Explorer, the Hubble Space Telescope, Wilkinson Microwave Anisotropy Probe, and the Planck Observatory have also been contributed and immeasurable values in these researches. Today, cosmologists have fairly precise and accurate measurements of many of the parameters of the Big Bang model, not to mention the age of the universe itself. And it all began with the noted observation that massive stellar objects, many light years distant, were slowly moving away from us. And while we still are not sure how it will all end, we do know that on a cosmological scale, that won't be for a long time. So that was the Big Bang theory according to science, according to scientists, according to cosmologists, astronomers. In the upcoming episode, we will be talking about the same things, the topic of creation of this universe, and we will continue to give you informations in all different perspectives. So our upcoming episode will be very interesting because it will cover up same things in Vedic manners, in ancient text manners. So make sure to listen that and make sure to check it out, because our history was very vast and our culture is very powerful. So thank you for listening to me. I will meet you in next podcast. Thank you.